Hello, I'm a high school senior who took AP-CSA last year and scored a 5. This is going to be a series of videos where I go through the new AP-CSA curriculum to help you through the class and eventually the exam. I wanted to do this for mainly two reasons. First, with the updated curriculum, all of the videos made for this course previously are now outdated. And second, all of these videos I feel miss the authenticity I hope to provide from being an actual student who took the exam. Without further ado, let's go. First is Unit 1, using objects and methods, making up 15 to 25% of the exam. And in this video, we're going to be covering topic 1.3, expressions and output. System.out.print and system.out.println display information on the computer display. System.out.println moves the cursor to a new line after the information has been displayed, while system.out.print does not. So, if we have code set up like this, using println, the numbers are output in different lines as so, because after each number is output, the cursor is moving to the next line. But if we have something like this, using print instead of println, the numbers are all in a single line. A literal is the code representation of a fixed value. An easy way to remember what a literal is to use the definition of the word itself. If we set up a variable like this, 5 is a literal here because it literally means the value of 5. It is not a representation of something else. The x is a variable holding the value of 5 and does not literally mean x, so it is not a literal. A string literal is a sequence of characters enclosed in double quotes. Let's say we want to output the letter x to the terminal, so we set up our print statement like this. However, there is an issue with this code. If we run it, it is going to output 5. This is because the computer is outputting the value of the x variable we created earlier. We need to show the computer that we don't want to output the variable x, we want to output the letter x. We do this by putting the x in double quotes. These double quotes create a string literal, saying I want to output literally what I just typed. Strings can be any length and can be a combination of any characters. Escape sequences are special sequences of characters that can be included in a string. They start with a backslash and have a special meaning in Java. Escape sequences used in this course include double quote, backslash, and new line. Escape sequences are used to format strings more precisely or include special characters that may be confusing to the compiler otherwise. First is the double quote. As you now know, how we signify that something is a string is by enclosing it in double quotes. But what if we wanted to also include double quotes in the string itself? Let's say we want to print the sentence, Bob says hello. We would do this with the double quote escape sequence, as so. Next is the backslash. Let's say we want to print the file path for the Sublime file I am working on. In this string, the backslashes are the issue. As we are going over right now, the backslash is used to signify that we want to start an escape sequence. So in order to show that we are actually using a backslash in the string, we must include 2. Lastly is the new line. Let's say we want to print the sentences, I am the first line, I am the second line. We can do this by including the new line escape sequence in between them. Yes, my keen viewer, this can also be done by breaking apart the sentences into 2 separate print statements and using println. This is just an alternative way to do it by using only one. Arithmetic expressions, which consist of numeric values, variables, and operators, include expressions of type int and double. In your math class in elementary school, you learn the difference between an arithmetic equation and expression. An arithmetic equation includes an equal sign and an expression does not. Arithmetic expressions in Java are the exact same thing you're familiar with, except it is not just operators and numbers, but also can include variables. The arithmetic operators consist of addition, subtraction, multiplication, division, and remainder. An arithmetic operation that uses 2 int values will evaluate to an int value. An arithmetic operation that uses at least 1 double value will evaluate to a double value. The ones you should already be familiar with, addition, subtraction, multiplication, and division, are signified with a plus sign, a minus sign, an asterisk, and a forward slash, respectively. The one you may not be familiar with is remainder. All the remainder operator does is divide the 2 numbers given, but return the remainder instead of the quotient. For example, 10 divided by 3 equals 3 with a remainder of 1. So, 10 remainder 3 would return 1. On another note, let's say we wanted to assign the variable x to the value of the arithmetic expression of 5 plus 4. 5 and 4 are both integers, so x's data type has to be an integer. However, if 5, 4, or both were doubles, x has to be a double as well. When dividing numeric values that are both int values, the result is only the integer portion of the quotient. When dividing numeric values that use at least one double value, the result is the quotient. Let's set up a print statement and say we want to output the value of 10 divided by 3, the quotient of 10 divided by 3 being 3.3 repeating. However, if we were to run this, our output would only be 3. This is because of something called integer division. If you remember from just a few seconds ago, because both 10 and 3 are integers, the expression must evaluate to an integer. Therefore, when the computer is evaluating the expression, it is essentially ignoring the non-integer part of the answer. In order to get the full quotient, we must make at least one of the numbers a double. This shows that we want the output to be a double and gives us the full quotient. Operators can be used to construct compound expressions. At compile time, numeric values are associated with operators according to operator precedence to determine how they are grouped. Parentheses can be used to modify operator precedence. Multiplication, division, and remainder have precedence over addition and subtraction. Operators with the same precedence are evaluated from left to right. This learning objective wants you to take 3 things away from it. 1. Arithmetic expressions can be any length. 2. They follow PEMDAS. And 3. In PEMDAS, remainder is grouped with multiplication and division. An attempt to divide an integer by the integer 0 will result in an arithmetic exception. Since dividing by 0 is mathematically impossible, if you set up an expression to do it, it will cause a runtime error and give you an arithmetic exception. However, if you divide a double by 0, it does some weird funky stuff. Luckily for you, it is outside of the course scope and you do not have to worry about it. Just think number divided by 0, arithmetic exception. And that brings topic 1.3 to a close.